These projects play an important role for the sector. They promote the research from the two most important points of view. The research part, which is the part that who develops the technology beyond the current state of the art. And on the other hand, we have the direct involvement for the industry or the interested parts that are going to apply this technology in its use case. This synergy creates from the beginning of the project, directs and focus the results towards something that is really applicable and interesting for the future progress into the robotics sector. In Robotnik, we are involved in several R&D projects with different topics, where we are mainly in charge of the development of the robotic platforms and the technology related with them, and also the integration. In these projects, there are different developments related to technologies that are applied to different use cases or real applications that evaluate the results and try to improve this technology. One of the projects that I am mainly in charge of it's FASTER. And FASTER, it's a project that offers and applies new technology such as an aerial or ground robots for rescue operations carried out by emergency teams in cases such as earthquakes, floods, or building collapses. In this project, we are participating, offering two platforms, the Summit XL and the RV car, for autonomous navigation, to explore the area using autonomous navigation, at the same time that we are offering a 3D map of the environment to know how is the situation in this kind of places. There are another project, it's ODIN, that mainly try to integrate technologies for services in hospitals, mainly regarding logistic operation and also the interaction with patients and other staff. Here we are participating with our RV1 base that should be in charge of the autonomous navigation at indoors, and also to integrate on top of it other technologies provided by other partners. Another project where we are developing mostly the main robotic platform for it's BACCHUS. In BACCHUS, the idea is to automate in a highway precision and a selective harvesting operation using mobile handling robotics, trying to imitate the same mechanism that the operator performs. That is using the two coordinated arms for collection the grapes and try to be optimal. The last project that I would like to mention is ODYSSEUS. In this case, this project is a security project aimed at detecting gases or elements with a high degree of explosiveness through the use of UGV sensory sight, specifically for this purpose. Inside the FASTER project, the RV car vehicle from Robotnik, it's used for rescue operations at outdoors mainly. It offers autonomous GPS navigation with the capacity to explore unknown areas, and it has the ability to create 3D map of the environment at the same time that offers a real-time streaming from the sensors. The different sensors that are integrated in the vehicle, such as thermal cameras or RGBD cameras, or the data coming from the LiDAR sensors. This information goes to the checkpoint where usually the operators are safe and monitoring all the operation. This robot has also a capacity for 2 people and of course can be driven manually. And one of the functionalities that it's inside the project is, for instance, that the vehicle initially saves the GPS position, where is the checkpoint where the people is safe. And for instance, it can be driven manually by a person while it's observing and checking how is the situation. Once something of interest appears, or is some person is found or something like that, the driver can get out from the vehicle to attend the person and can send autonomously the robot back to the safe position where it started. In this case, for instance, the vehicle can be able to act as a mule vehicle, transporting materials from one point to another one. Inside the same project, faster, we are also participating with the Robot Summit XL, that is smaller than the RB car. So it's more oriented to the exploration at indoors environment. It also offers the possibility to be to get autonomous navigation inside the buildings, and also, of course, outdoors. And also, at the same time, can provide the 3D mapping operation and streaming the video as the RV car does. Well, to mention just one of them, I think that the dynamic and unpredictable environments are one of the most critical factors in providing a solution applicable for different environments or use cases. Also, the sensory technology, despite being rapidly advanced, still doesn't offer solutions with the precision required by many applications. I think also the main important probably is that the technology transition gap between the research community and its end users. Nowadays, it's difficult to offer products or results of these projects that are within the research of the knowledge and the usability of a non-expert user in the field. There is still a long way to go to relax this difference between the technology provider and the end user. The day when people can use robots like someone who puts a washing machine or a dishwasher is still a bit far away. In indoor logistics, it's clear that the autonomous organization of warehouses and the internal transport of goods is in the order of the day. Furthermore, the innovation lies in the fact that mobile vehicles that are used to move on a fixed lane within an assembly line, for example, the autonomous guided vehicles, now they are autonomous mobile vehicles, so they can move freely on the ground, being able to modify their trajectories and offering greater flexibility. Meaning also that the customer doesn't need to modify the environment or even install something in particular for that. In this field, the fleet of heterogeneous robots that can autonomously coordinate between them to accomplish tasks in an optimal way is the most popular researches right now. One of the most used robots oriented to indoor environments is the RB1 base, a differential robot that can navigate autonomously moving service or goods up to 50 kilograms of payload. In another hand, the outdoor logistic, there are also great advantages where mobile robotics is applied. For last mile robot-oriented applications, for instance, where autonomous vehicles are used to transport goods, packages, or whatever during the last part of the routes, or short paths, for example, picking up trash, delivering packages, collecting fruits, etc. Of course, with topics like the transport of goods by road, for example, there is still a long way to go, but the research is working on that, so it's something that we should see in the future for sure. The RB Bogie robot is one of the most used robots for outdoor logistics. It can navigate autonomously, and with an arm manipulator mounted on the top of the base, it can interact with objects in the environment, picking trash from the floor or collecting, for instance, some samples of interest. The automation in the agriculture sector is not really new. There are a lot of big machines, trucks, tractors with machinery specialized in picking up fruits or vegetables. Some tractors that can just shake the trees and collect all the fruits that are falling down. Others that can, for instance, cut all the trees with the same shape or with the same form of the shape. But the results that these machines can offer cannot be compared with the work done by operators that are specialized in the field. The operator who knows just to look in the fruit if it is ready to be picked or if it needs more time to be more mature, or maybe the grape that it's the best for the perfect wine production. This is why the precision agriculture was born, and where robotics has a lot of benefits to offer. Apart from the obvious advantages, like working without human supervision or working at night, etc., the main idea is to provide to the autonomous robots the ability to identify, as humans do, the best choice to actuate with the environment, providing optimal results closer to the same or even with better quality than the human operator can do it. Inside the BACCHUS project, the RB Bogie XL mounts two arms manipulator to autonomously harvest wine grapes like a human will do, using one arm like the hand that has the scissors to have to cut the bundle, and the other hand with an end effector that has to actuate as a hand picking the whole bundle and making the operation like the human will do.